Hello everyone. Today we'll be solving problems related to steady state situation. Okay. Uh, First, we look upon this thing. Okay. See, if this is a battery having internal resistance R1, another battery having internal and this is connected with a resistance of R, right? Right. So, if you need to calculate what is the current to this circuit, right? If current I is flowing, what will be the current through this circuit? It will be total EMF upon, or you can say total voltage, okay, in series upon total resistance, okay. So total EMF will be for this circuit, it will be E1 plus E2. Why so? Because they both are in same polarity. See, the bigger one is plus, the smaller one is minus. So this is a plus, this is minus, okay. So net EMF will be the summation of both. If combination was something like this, this is there and something like this, okay, then the net EMF will be the uh, subtraction difference of the both, okay, E1 minus E2 or E2 minus E1, right? So your net EMF is E1 plus E2, right? And your net resistance will be, means total resistance. The R1 is in series with R2 and they are in series with capital R. That means R1 plus R2 plus, this will be the net current through this circuit, okay. Now you need to note down one thing, that in steady state branch containing capacitor, don't worry, I'll tell you the meaning of this statement, okay, you just write it. In a steady state branch containing capacitor will have no current through it, okay. uh, what do you mean by steady state here? Here, under steady state, let's say a capacitor is here, okay, it is connected in a circuit, something like this, okay. In a steady state, this capacitor is going to offer infinite resistance. That means this circuit will behave as open circuit, right? There is no connection, means resistance having infinite, okay. So if your resistance through the circuit is infinite, what will be the current? Current will be zero, or you can say no current is flowing through it, okay. So always remember, in steady state the capacitor will behave as a open circuit, or you can say the capacitor will be offering infinite resistance, okay. Now we'll understand this by a problem. You have your circuit like this, right? The resistance R1, okay, the resistance R2, right, and this is connected with a resistance capital R, okay, and connected with the capacitor C, right? R1, R2, E2, and E1, okay. Now you need to find the charge on the capacitor C, okay. Find Q on capacitor, right? And one more thing is given, that E2 is greater than E1, right? So if see, the current will always originate from the positive one, okay. If E1 was greater, then direction of current would have been like this, okay. But here in this situation E2 is greater, right? So the direction of current will be from E2 to E1, right? Means this will be the direction of current. right? So you know that if see, if we consider the potential difference across this resistance is V, okay, you know that if current I is flowing, okay, like this, okay, like, see, you need to find a charge on the capacitor under steady state, right? You need to find this, okay. Now you know that under steady state there will not be any current flowing through the branch containing capacitor, means here there will be no current will be flowing through this, right? So all the current originating from this will pass through this and enters on E2, right? So you know V is equals to I into R, right here. And this V is what? This is the potential difference across this resistance capital R, okay. Here you know one more relation, that Q is equals to C into V. So Q is equals to C into, you can write V as I into R. Q is equals to C into R. Now what will be the value of I? In the previous slide I have told you how to calculate I. See, these two batteries are in opposite polarity, okay. This is a positive one, this is a positive, this is negative, this is negative, okay. I have told you that when they are in same polarity, means in same direction, negative positive, okay, then the resistance gets adds up, okay. But here they are in opposite sense, so your current will be E2 minus E1. Why E2 minus E1? Because E2 is greater, okay, upon total resistance is the resistance offered by this battery E1 plus resistance offered by battery E2 plus the resistance of the circuit, okay. That means R1 plus R2 plus, this will be your charge on the capacitor under steady state situation. We'll be studying this more in the growth and decay of charge, okay, so don't worry about this, okay. uh, Solve one more problem, okay. I'm giving you here your capacitor having 5 microfarad, okay, the circuit, resistance having 1 ohm, okay, another resistance having resistance 1 ohm, okay, the capacitor of 5 microfarad, and the in its branch there is a 1 ohm resistance as well, okay. And your battery here, it is connected in this sense, okay. This is 0.5 ohm and this is 0.5. Now you need to find the charge on the capacitor under steady state, okay. Q on the capacitor under steady state, okay. See, I have told you that under steady state the branch containing capacitor will have zero current, okay. Suppose current I is originating from here, right? I right, okay. This circuit means the circuit in which the capacitor is connected, this circuit will be having no current, okay. So if this is current I, then its value will be 0, okay, because there will not be any current flowing through the branch containing capacitor, okay. So the net current that is originating, all the current will flow pass through here, will be I, will be I. So it is very simple, okay. You can calculate the net current I, it will be net EMF upon total resistance. EMF is 2.5 volt, okay. There is only one battery connected, upon total resistance will be this resistance plus internal resistance of the battery, okay. See, this resistance will not be playing any role, because why so? Because no current is flowing through it, okay. So this will be offering zero potential, okay. So your current I, it will be 1 plus 1 plus 0.5, that means I will be 1 ampere, okay. You have got your current, okay. Now if you see that potential difference across this circuit, you consider it at point A and this as point B, okay. The potential difference across this circuit will be the potential due to this capacitor plus the potential due to this current I, because this the potential due to this resistance 1 ohm, okay. Because see, since this resistance, the resistance 1 ohm, this is no current is passing through this 1 ohm resistance. Okay, so this resistance will be offering no potential. Okay, so the net potential through this uh, between these 2 points A and B will be the potential due to the you can say the capacitor. Okay, the charge on the capacitor. Okay, now you know the potential V is equals to I think Q equal to CV, so V equal to Q by C, right? And you need to calculate Q equal to C into V. Okay, we have got the value of C, it is given 5 microfarad. We only need to calculate the potential difference, right? So potential difference will be what? It will be, see, this is a point A, this will be also point A, this will also be point A, because there is no potential drop across a conducting wire. Okay, this is a point B, this will also be point. Okay, if you see the potential drop across this 1 ohm resistance, it will be 1 into 1, because current is 1 ampere and potential resistance is 1 ampere, plus the potential drop across this, it will also be 1 into 1, it will be 2 volt. Means the potential difference across this part is 2 volt. So this will also be the potential difference across A and B, because they are same points. Means VA minus VB, it will be 2 volt. And this is what the net potential which we need to put here. Okay, so Q will be C into V. Sorry, uh, your C is given as 5 microfarad to 2. That means 5 to the 10 microcoulomb. This will be your the charge on the capacitor under steady. Okay, so this was one problem. Okay, to practice more problems on steady state. Okay, in the next video we'll be studying about the combination of two charge capacitors. Okay,